Good day everyone. Again, this is Engineer Freedom PJ Carodan or Engineer FPJ. For this video, I'm going to discuss again the analysis of indeterminate beams. But under na siya ng what method? So we have an alternate way for moment distribution method, which we can call the modified moment distribution method. Okay. So in the regular procedure of MDM kasi, di ba nga, we lock all non-fixed support. So in the regular process for MDM, it will give you too many iterations because you are going to unlock and relock the supports. So in this video, there is an alternate way to solve these problems for the indeterminate beams. Okay? So yun ang i-discuss ko today. Okay, so yan. So, pwede ka bang ilagay mo na sa drawing table ko? And let's consider this beam shown. Okay. So, we have this beam and then, so an alternate way to solve this is to, okay, so unang step natin is to lock all the non-fixed support. Okay. And then, solve for the fixed ended moment for the two segments here. Okay. And then, ang una nyo gagawin is to unlock the rightmost support to its original condition of support. Okay. So, kapag nasolve nyo na yung FEM for this segment, is that ang gagawin nyo is to release this lock support at the rightmost or leftmost part of the beam. Okay? So, kapag pagka-release nyo yan, siyempre babalik yung value ng moment dyan, which is the opposite of the solve moment for this support. Okay? So, ayan, para mas madali, kapag in-unlock nyo yan, yung moment dyan is the opposite sign of what we solve from the fixed-ended moment. Okay? And then, so, ayan nga, after nun, unlocking the internal support, will then instantly return the beam to its original support, giving us a single cycle only. So, itong modified is very, very useful siya kapag we have more than 2 spans. Okay? So, for this, so, unlocking the internal support, makikita rin naman siguro if we unlock the support here. So, pag in-unlock nyo yung rightmost support, di ba magiging negative siya. Okay? A negative nung value of the moment that we solve from FEM. And then, we will add this moment or half of this moment to this fixed support here at our internal fixed support. So, makakakuha tayo dyan ng, so yung moment dito, i-add natin sa internal moment at that internal support. Okay? And then, kapag nirelease naman natin tong internal support here, there will also be what we call a unbalanced moment from this locking moment that we had from solving the fixed-ended moment. So, after that, we solve for the unbalanced moment. Therefore, isa-solve natin yung ating distribution factor. And then, we have to distribute it from the fixed support at the leftmost part of our beam. Okay? So, yung beam natin will look like this. Okay? So, ganyan yung kalalabasan niya. After unlocking this rightmost support and then unlocking the internal support. So, we have a prop beam at the left side of our beam and then simply supported beam for our right part. Okay? So, yung distribution factor K could be solved with this absolute stiffness. So, 4EI over L. And for simply supported naman, we have a stiffness factor of 3EI all over L. Okay? So, kung magulo yung pag-explain ko, so, ano na lang siguro, let's have an example to simply understand this concept. Okay? So, yan. And so, let's have this example. So, example 1, consider the continuous beam loaded as shown. So, our E is constant. So, EI dapat is constant. Okay? So, mali yan. And then, determine the moment it supports A, B, and C. Okay? So, first na gagawin natin dyan is to lock all the non-fixed support. Okay? Ayan, lock mo na. Ayan. And then after that, we have to solve for the fixed-ended moment between these two spans. Okay? So first is within span AB. So I'm going to solve for the fixed-ended moment at AB, which is moment near A but and then far sa B. Okay? So given lang siya as PAB squared all over L. Since meron tayong dalawang concentrated load, 15 times 2 times 6 squared all over 8 squared. So total na length. And then for 12 kilonewton load, lagay ko na lang agad. We have 12 times 5 times 3 squared all over 8 squared. So therefore, ang moment at A is equal to 25.3125. So since ang assumption natin is pa ganito, ito, and then for this part is ganyan yan. So we have moment negative 25.3125. Okay? And then for fixed-ended moment for BA, babalik ta rin lang natin. Okay? So 15, 2 squared times 6 all over 8 squared plus 12 times 5 squared times 3 all over 8 squared. So, ang answer natin dito will be equal to 19.6875 nakalimutan ko, kilonewton meter. So, dapat naka-kilonewton meter siya. Ay, nawala. So, lagay ko na lang dito. Nawala. AB is equal to negative 25.3. So, 25 yan. 3125 kilonewton meter. And then for FEM BA, so it is 19.6875 kilonewton meter. Okay? Palitin natin. Malalaki. Okay, yes, ayan, mas maganda. And then, solving for span BC. So, FEM BC. So, kapag yung assumption natin is pa ganyan, and dito is clockwise. Okay? So, since span to span naman yung distributed load natin, so meron na tayong formula dyan, which is WL squared all over 12. So, equal siya sa 6 times yung total length, which is 11, squared all over 12. Okay? So, answer at fixed-ended moment BC, assuming that it has counterclockwise, is negative 60.5 kilonewton meter. Okay? And then for FEM CB, parehas lang din yan since magka-counteract siya dito. Our moment at that rightmost part is 60.5 kilonewton meters din. Okay? So, nasolve natin yung FEM, ABN, AB, BA, at BC, and CB. So, pwede bang ayusin ko lang? Okay? So, yan yung moments at the support reaction. So, hindi pa yan yung final, okay? That is just the fixed-ended moment, okay? So, ang first na gagawin natin by my first discussion is that we have to release our rightmost support or leftmost support. So, since ito lang naman yung ating non-fixed support, so ito yung re-release natin, and then by discussion that when we release this part is that babalik siya in a different sign na so that it can cancel out. Okay? So, ang concept dyan is kapag ni-release nyo yan, magiging negative yung ating moment dyan. And then, okay? And then, ililipat natin yung kalahati ng moment dyan sa kabila. Okay? So, therefore, ganito lang yan. Since, ililipat natin siya sa support B. So, 60.5. Itong support B na yan. And then, dadagdagan natin siya nung kalahati nung opposite nung moment at C. So, kalahati nung 60.5. So, therefore, ang magiging moment sa B should be equal to negative 90.75. Okay, so papalitan ko yan ha. So, nadadagdagan siya ng kalahati. And then, yung moment dito, of course, since bumalik na siya sa original na support condition niya, which is simply supported. Sorry. So, okay lang yun. And then, ayun nga, since bumalik siya sa dati niyang support condition, so, ang moment dyan should be equal to 0. Okay? So, ayan yung FEM natin at the the supports A, B, and C. Okay? So, ayan. After nyan, is i-unlock na natin tong non-fixed support na to since nakalock pa rin siya. Okay? So, yung ating beam will look like this. Ayan. So, yung left side is magiging prop beam and the right side will look like a simply supported beam lang. Okay? Kapag in-unlock natin yung support at B. Okay? So, therefore, kapag in-unlock natin yan, again, there will be a since ito yung locking moment, kapag in-unlock natin yan, meron tayong magkakaroon tayo ng unbalanced moment dyan. So, yung unbalanced moment dyan, syempre, paghahatian nung dalawang segment dyan. Okay? So, hanapin muna natin yung tinatawag nating distribution factor. Kung ilan yung kukunin ng kabila and nung other span. Okay? So, solve muna natin yung unbalanced moment dyan, which is the negative sum of our locking moment. Okay? So, 19.6875 plus, okay, di plus, minus 90.75. So, yung unbalanced moment natin will be equal to 71.0625 kilonewton moment. So, yung unbalanced moment na paghahatian ng dalawa will be equal to 71.0625. And then, when we solve for the distribution factor, so meron naman tayong formula dyan for prop beam and cantilever beam. Okay? So, which is equal to, so for our prop beam, K is equal to 4EI all over L. So, KAB muna. Okay? And then, for K BC, equal siya sa 3EI all over L. Okay? So, solve ko na agad. K is just equal to KAB. 4EI. 4, since prismatic naman yan, 4, and then total length, which is equal to 8. So, it is just EI all over 2. Okay? And also, 1/2 lang EI. 1/2 EI. So, KBC naman is equal to 3 EI all over total length of BC is 11. Okay? And then, when we try to find the distribution factor for both segments, DFAB muna tayo. DFAB is just 1/2 over 1/2 plus 3 over 11. Okay? So, our distribution factor for AB is equal to 0.647. And then, alam naman natin that the distribution factor should be equal to 1. So, ang distribution factor for AB is 0.647 and bawasan nyo ng 1 since 1 dapat 100%. So, ang distribution factor for the right side is equal to 0.353. Okay? So, what is the 64.7% of saan na yan balance natin? 71.0625 is yun yung makukuha nung left side ng span natin, which yung sa AB span, okay? So, 0.647 times 71.0625 is equal to 45.977. And then, sa kaliwa naman is just yung unbalanced moment natin times kung ilan yung makukuha nung span BC natin. So, 71.0625 times 0.353 is equal to 25.085. Okay? So, yan na yung tinatawag natin na first distribution. So, ito yung DF. Okay? So, since fixed support yan, so hindi naman natin siya in-unlock. So, 0 yung distribution dyan. And then, 0 rin to. Okay? So, next is that, kailangan na natin siya i-carry over. So, yung kalahati nito, lilipat ko doon. Ayan. And then, kalahati nito, lilipat ko doon. Okay? So, gagawin ko yan. So, half of 45.977 is equal to 22.989 kilonewton meter. And then, ito, wala naman dyan. So, 0 yan. And then, ito, okay, mali ako dito. Sorry. So, yan, mali yan. So, there will be no carryover moment at C because it cannot develop resisting moment since simply supported lang naman siya. So, wala siya makukuha na carryover moment. So, ito lang yung ating carryover moment for this problem. So, after nyan, so, meron na tayong one cycle na tinatawag. Therefore, we just have to sum up these moments sa nakalagay ito sa table natin. Okay? Ayan. Lagay ko dito. Sum. Okay? So, kapag sinam ko yan, itong part na to, 25 plus 0 plus 22.89 is negative 2.3235. And then dito naman is equal to 65.665. And for this span here, internal moment pa rin yan, 66. So, kapag chinek nyo yan, dapat parehas lang din. Okay? So, 60. This should be 65. 65.665. And then dito, since external support siya, and then simply supported, 0 ang dapat na magiging moment dyan. So, this will be our final answer for our problem number 1. So, ito yung moment. Moment at BA, moment at BC, and then moment at CB. Okay? So, yun lang yung ating problem for this, yun lang yung solution for this problem. So, napadali siya. Hindi na tayo nagkaroon ng madaming iteration. So, hindi na tayo magla-lock, unlock, and then we have to solve hanggang maging negligible or very small yung ating moment. So, ito na lang yan for our modified moment distribution method. Okay? So, yan yung example number 1. So, wait pa kayo for other example. Okay? Thank you for listening and abangan